In this lecture presented by www.free-academy.com, we're going to estimate the area underneath the graph f of x equals x squared divided by 2 between -2 and +2. And we're going to do this by using 8 rectangles. So we've seen in our previous lecture that we can solve this by either setting our rectangle so that the left-hand corner hits the graph, or we could also set it so the right-hand corner hits the graph. But this problem is asking us to use x of I as the midpoint. So what does that mean? Well, specifically, I'm actually going to blow up my graph here a little bit for illustration. And let's say this is 1 and this is -1. Instead of setting it so a particular rectangle will hit on the left like that, we'll set it so the middle of each rectangle actually goes on the graph. And this is a little bit more accurate of a means of estimating the area, because you're always going to get a little bit of an undercut and a little bit of an overcut on each one of these rectangles, and they cancel out just a little bit better, or as opposed to if you're doing the right hand side per se, you have a massive overestimation on this side here. So doing the middle is definitely better, and we're going to learn how to do that. We're going to practice that technique. Alright, for starters, we need to find what our delta xi is, or this can also be construed as the width of each one of these rectangles here. And that's going to be fairly straightforward to find. We're going to take our range, which is 2 minus 2, which is 4. 1, 2, 3, or 1, 2, 3, 4. And we're going to divide it by the number of rectangles, which is 8. And our width is going to be equal to 1/2. So we're going to set this into our formula. Our area is going to be equal our width. And then it's going to be multiplied by the sum of our different heights here. Now, the next thing to do is to figure out what our midpoint of each rectangle is. If we're to set our left-hand corner of our rectangles, then our first rectangle would occur at f of -2. This would be the height of our first rectangle if we're doing the left hand. But we're going to be doing the middle point, so we have to go 1/4 in from -2. Which is going to be -7/4. So our first rectangle's height is -7/4. -6/4 is the right-hand side. -8/4 is the left-hand side, so the middle is -7/4. And because our width of each one of these rectangles is 1/2, we're going to have to move 1/2 over for each one of these rectangles. So f of -7/4 is the first one. We got to move 1/2 to the right from that. So this will be -5/4. 1/4 is the same, or 1/2 is the same as 2/4. And then we have to move 1/4 or 1/2 over from that, so it's f of -3/4. And we move over another half from that, so that's -1/4. And then we go on to the positive side. 1/4 plus 1/2 is +1/4. +3/4, and so on. And this will go all the way up to +7/4. I suppose I only skipped one, the 5/4. So now we have the width and we have the height, and the height is actually made by doing a sum of our different rectangles here. So this is going to be the width times the height of our first rectangle plus the width times the height of the second rectangle. And if you add together all 8 rectangles, you're going to get an area for underneath the graph. So now it's a matter of actually evaluating these. Notice that this function is f of x equals x squared divided by 2. So what I'm actually going to do is I'm going to pull out the 1/2 to make this 1/4 as our leading term here. So now it's just a matter of taking each one of these as x squared. And that's actually really simple to do. We can do that in our heads. Minus 7 squared is 49 divided by 4 squared, which is 16, plus minus 5/4 is positive 25 divided by 16, plus 3/4 is 9 divided by 16. 1/4 squared is 1 over 16. And these all came out positive. Of course, whenever we square our positive terms, we're going to get the same thing. So this will be plus 1/16, plus 9/16, plus 25/16, plus 49/16. So now we can all add those all together and then multiply the 1/4 through. And what we're going to get is 84 over 16, which we can then simplify to be 21 over 8. And if you want that in a decimal, that's exactly equal to 2.625. The area underneath this graph is equal to 2.625 between -2 and +2. And just to give you an idea of how good this estimation is, the exact area underneath it is 2.66 repeating. So we're only off by 0.04 approximately, and that's only using 8 rectangles. So sometimes these estimation techniques can be really, really good when it comes to solving graphs, or solving for the area problem. So that's this lecture by freeacademy.com. In the next lecture, I'm going to cover how to do this with the trapezoidal approximation, which is even better.